we're going to look at some vocabulary with angles and how we measure some things. So the first thing that you need to know is that we've got what we call a central angle. So this is where the vertex is at the center of the circle. So this picture here, we've got this would be our central angle. Now we also have something that we call a minor arc. So that's like the technical definition is the points that are on the circle that are on the interior and the side of the central angle that is less than 180 degrees. So what I like to think of it is the crust part of your slice of pizza. You also have the major arc, and that's going the rest of the crust that you have. So this would be the major arc, and then this one would be the minor arc. So the difference between your major and minor is that the minor is less than 180 degrees and the major is more than 180 degrees. Then we also have a semicircle. The endpoints of the circle, or of the arc rather, are on the diameter. I didn't draw that centered superbly well. So this would be a semicircle, so basically half of a circle. Well, now we need to talk about how we name the arcs. So we use the endpoints, similar to how we do segments. But instead of drawing a bar above it to show a segment, we draw an arc above it. Okay, so this would be the yellow arc. We'd call that CB, and we do an arc above it. And if we want to talk about the measurement of that arc, we would use that little m to show that measurement of that arc. Now for major arcs, you need to have some kind of differentiation, because if I say CB, I need to know if I'm talking about this one or this one. So if you have two letters, you know that it's the minor arc. If you want to do the major arc, you need some other letter on the circle. So if there's not one there, you can put one there to show that you're going the longer direction around. So then our orange one would be the arc CDB. And again, the order doesn't matter, so I could have called this BC, or I could have called this BDC, right? But I do need that D in between the C and the B so that I know I'm going this direction, or you could come this direction like that. Now, we also need to know how we measure them. So the measure of a minor arc is the same as the central arc. Not central arc. Central angle. So change that for me. It's the same as measure of the central angle. So if this angle here was 65 degrees, then this arc would be 65 degrees. Okay? Now you also can measure the length of this. We're not working on that right now, but you can measure the length of this. But if you're talking about the degree measurement, it matches the degree of the central angle. And then the way that you find the major arc is you're going to do 360 minus the associated minor arc. So if this is my minor arc and this is the major arc, because there's 360 degrees in a circle, I'm going to do 360 minus this minor arc, which will give me this whole outside portion here. So go ahead and pause and try these three and see if you can find the measurement of the arcs, both the minor and the major. Okay, so you should have paused and have your answers. So because our central angle for cab is 45, that means that the measure of this minor arc is 45 as well. To find the measurement, so we would say the measurement of arc CB is 45. To find the associated, or the major arc, we want to do 360 minus that. So the measurement of CDB would then be 360 minus the 45. So then that would give us 315. Similarly here, we've got this central angle is 75, so this arc would be 75. And then this arc going all the way around would be 360 minus the 75. So the measurement of CB is 75, and then the measurement of CDB is 360 minus 75, so 285. So if we do this one, this angle is 112, so this is still a minor because it's still less than 180. So then our measurement of this arc would be 112. Oops. So DB would be 112. And then to find the associated arc on this one, the name is DEB. So I'm going to do 360 minus 112. So if I do 360 minus the 112, that gives us 248. So that's how you find your measurements of the arcs, both major and minor arcs. Now we have something that's called the arc addition postulate. So the measurement arc formed by two adjacent arcs is the sum of the measure of the two arcs. We've done two other addition postulates. We had done the segment addition postulate and the angle addition postulate. So if I put some letters on here. Okay. So if we've got arc CB, excuse me, is 40 and arc BD is 45, right, then that means that arc CD, so we would do the measure of CB plus the measurement of BD equals the measurement of CD. So what we're really doing is this part plus this part equals the full thing. So we've done one with a segment and we've done one with angles, but it's that same kind of thing, but now we're just doing it with arcs instead. So you're thinking part plus part equals whole. And we also have on this one that if you're looking, if I give you the central angle on this one and then the arc on this one, I use the idea that the central angle is the same as the minor arc. So then I can say, well, if we know that's 40, then we know the arc is 40. So then I can do 40 plus 45 gives us 85. So the arc of CD would be 45. I don't need 3 letters on this one because it's less than 180 degrees. Right, so it's less than half a circle, so I don't need to worry about using a third letter. Okay. If I wanted this one, I would need to throw in another letter here, so I could say that it's this direction. Okay. We also have congruent arcs. So we've got 2 arcs of the same circle, or congruent circles that have the same measurement. Right? Remember we talked about congruency is that their measures are the same. Okay. So we have that as well. So if we look here, okay, we've got find the measures of the following arcs. So here we've got the central angles on all 3 of these. So since the central angle is 45, then that means that this arc ED is 45. Since the central angle of CAE is 70, I know that the arc EC is 70. And since we know that CAB, angle CAB is 110. That's the central angle because it comes in the vertexes at the center. We know that arc CD is 110. So if I wanted to find like the measurement of arc DC, then to find DC, I need to add these 2 things together. So I would do 45 plus the 70. So then that gives us 115. Now, I also could do where you would need to think in terms of the fact that this is a diameter here because it goes through the center. Okay? If I didn't have this piece of information up here, if I had none of this up here and I just had that this was 45, you can still find this measurement here because you know that it goes through the center. So you know that this is a diameter, so there's 180 degrees in this angle here. So to figure out what this measurement would be, we would have to do the measurement of arc DB would be 180 minus the 45. So 135 degrees. So when you're looking at these, you want to pay attention to if you have a diameter or not, and if you can use that to help you find the information that you need. Okay. Then we have a theorem that says in the same circle or congruent circles, which we had up here as well. So if they're the same circle or if you know that the radii are the same, then that would be congruent circles. So two minor arcs are congruent if and only if their corresponding chords are congruent. Now, this if and only if part means that it works forwards and backwards, right? So if we've got the minor arcs are congruent, then we know the corresponding chords are congruent. If we know the corresponding chords are congruent, then we know that the arcs are congruent. Okay. So this would be the corresponding chord for this arc here. This would be the corresponding dB, would be the corresponding chord for the minor arc dB. So again, it goes both directions. So if you have the arcs are congruent, then you know the chords are congruent. If you know the chords are congruent, then you know the arcs are congruent. This should have congruent. So it should have the tilde above it. Okay? So then we can use this to our advantage to know. So if I know that these two chords are the same, then I know that these two arcs are also the same. Right, so if I know those arcs are the same, then I can say that 10x equals 8x plus 24. So then I can subtract the 8x. So I get 2x is 24. So then we get x is 12. Now we can go the opposite direction. So here I know the arcs are the same. So this is 75 and this is 75. So then I know that these chords H, G, and J, I have to be congruent by that theorem that we had. There's not a specific name associated with it, so you can just say what the theorem is if you're trying to describe what you're doing in your problem. So here we can set 2x minus 3 equal to 15 because we know that the arcs are congruent, then we know that the corresponding chords are congruent. So then we solve this by adding the 3, so we get 2x is 18, so then our x is 9. So those are how we can name the arcs. And we've got the minor arc and the major arc. The major arc is more than 180 degrees. The minor arc is less than 180 degrees. The M next to it means that the measurement of your angles, of your arcs is the same as your central angle, right? So then you can use that piece of information to help you find missing parts. Then we've got the arc addition postulate that says if you've got a part and a part, then that you can add those together and that gives you the whole thing. We've got congruent arcs that have the same measurement, just like congruent segments have the same measurement and all the other congruent parts we've talked about. And then we know that if the chords are congruent, then we know that the corresponding arcs are congruent. If we know the arcs are congruent, then we know the corresponding chords are congruent. You can go both directions on that.